Today we're going to be looking at how we solve literal equations and all types of literal equations, not just ones that are solving for y. So today when we look at our equations, we're going to see numerous different letters happening, and our objective is going to be to solve for one of them. So we're still using the same concept of inverse operations. The difference is that instead of moving a number and combining like terms, we're just going to be moving a letter. So for example, if we want to solve this for a, right? We know that this W is being attached with addition and subtraction. This W is positive, and we undo a positive with a negative, so we'll subtract W from each side. Those W's cancel out, which would leave us with an A equals G minus W, right? G and W are not like terms, so I cannot combine them, so I just rearrange, and my final answer is A equals G minus W. Okay, so if I look at number 2, right, same concept. If I want to solve this for C, right, C is the variable I'm trying to get by itself. Over here with C is B. These two letters are attached with division, and I undo division with multiplication. So I would multiply both sides by B. These B's cancel out. So that leaves me with C equals D times B. Now you could write that as B times D as well. That would be fine. Right? But we don't know what that is either way, so we're just setting them next to each other. Now, we can have multiple operations happening in one problem, and we're still going to use the inverse operation. So one of the things I say to my students that often helps them is, for example, if we want to solve this for x, we could imagine replacing all of those different variables with a letter. So instead of saying x plus y, I could say x plus 3 all over 4 equals 5, right? Just replacing that y, z, and h with numbers. And we know that if we want to move this 4, we undo dividing by 4 by multiplying by 4. So we'll just find what's in that same position, that z, right? And we'll undo dividing by z by multiplying by z. So those z's will cancel, which will leave us with an x plus y equals hz. And then again, to finish solving, if I want to get x by itself, I'll undo addition with subtraction. Now, there's just more stuff over here, but there's still more stuff that I can't combine. So I'll get x equals hz minus y. If we look at number 4, 4 has a now added piece that we want to consider. So if we look at number 4, it's asking us to solve for h. And when we look at this, the important things to recognize is that all of these pieces here are multiplication. So it's 1/2 times b times h. That entire left-hand side is all attached with multiplication. And when that is the case, we can divide by all of the pieces we want to divide by at once. So I can divide by all of this 1/2 b that I need to get rid of. And I can cancel out that 1/2 and b at the same time. Now, this leaves me with h equals a over 1/2 b. Okay, and while we do have h by itself, we wouldn't say that this is simplified because we don't write a fraction within a fraction. So what we really want to consider is that this a has a 1 sitting in front of it. And so if I look at just this portion, I really have 1 divided by 1/2. And 1 divided by 1/2 will give me 2. So this would simplify to 2a over b. If I look at number 5, we just have to be real careful on this. It's really tempting to solve it for y, but if we read the directions, it tells us to solve it for x. So if we're going to solve this for x, we want to make sure we're moving that entire y chunk first, right? So I'm undoing subtraction with addition. And then we'll undo multiplication with division, remembering that multiplication and division always happen all the way through. So I'm going to divide all 3 of these pieces by 3. So that will give me x equals a 2/3 y plus 4. And then our last problem. So again, sort of looks complex. We might look at this and be like, I don't know what to do with an exponent. I've got this pi going on. I have all these pieces. But the important thing to note is that this is all multiplication. 1/3 times pi times r squared times h. which means if we want to solve this for h, we can divide by all the pieces we want to get rid of all at once. So I can divide by all that 1/3 pi r squared at one time, which means all of these pieces cancel out. Okay, and just like we said before, right, we don't want this fraction inside a fraction. So we're really imagining, right, that 1 divided by 1/3, which would give us a 3v over pi r squared equals h.